The cold arrived before the engine did. On a January morning in 1919 in Duluth, Minnesota, a hardware merchant named Walter Oakes spent 11 minutes cranking the starter handle of his Ford Model T before the engine caught, and in those 11 minutes, standing in his driveway, without gloves, because gloves made the cranking impossible, his hands had gone from cold to genuinely painful in the way that extreme cold produces pain that is distinct from ordinary discomfort. He climbed into the seat, which was as cold as the air around it because there was nothing between the seat and the temperature, and he drove the 4 miles to his hardware store on Superior Street with his coat collar turned up against the wind that entered the cabin from every direction a car of that era failed to seal against. The Ford Model T had no heater. It had no provision for a heater. It had no space where a heater might be placed, and no system from which heat might be drawn, even if space had been found. The engine produced enormous quantities of heat in the course of running. None of that heat went to Walter Oakes. It went into the air above the hood and dissipated over the roads of Duluth, while the man who had paid for the machine that produced it sat in the cold and drove. This was not considered a design flaw in 1919. It was considered a condition of automobile ownership, the same way that wet roads were a condition of rain and frozen roads were a condition of winter. The automobile had been designed as a transportation device and not as a comfort device, and the engineers who built the early cars had organized their priorities accordingly. The engine had to run, the brakes had to stop the car, the wheels had to maintain contact with the road under reasonable conditions. Whether the person inside was warm or cold was a question that belonged to the person inside and not to the engineering department. You dressed for the weather. You wore the coat and the gloves and the hat, and if the trip was long enough that you expected to be genuinely cold by the end of it, you brought a lap robe, a heavy blanket that you tucked around your legs before you started driving. This was what people did. This was what Walter Oakes did every winter morning for 7 years before anything changed. What makes this worth examining carefully is not the discomfort itself, which was real but manageable for most people most of the time, but the gap between the problem and the solution. The heat was already there. It had been there since the first internal combustion engine turned over in the first automobile. The engine produced heat as an inevitable byproduct of burning fuel, heat so substantial that the entire cooling system of every car ever built was dedicated to removing it before it destroyed the engine. The problem of cold passengers was, in engineering terms, simply a problem of heat being in the wrong place. Moving it from the wrong place to the right place was not a technical challenge that required new science or new materials or new manufacturing processes. It required a pipe and a decision. The decision took 30 years to make.
To understand why the car heater took as long as it did, you have to understand what early motoring was and who it was for and what the people doing it thought they were engaged in. The automobile in its first decade and a half of existence was not a practical transportation device for ordinary people. It was an expensive, unreliable, mechanically demanding machine that required its owner to understand it in a way that modern car owners are never asked to understand their vehicles. You could not simply get into a car in 1907 and drive it. You had to know how to start it, which was a physical process involving the crank and a sequence of steps that had to be performed in the correct order. You had to know how to maintain it, because the cars of that era required constant attention in the form of lubrication and adjustment and the replacement of parts that wore out faster than any reasonable person would have expected. And you had to know how to repair it when it broke, which it did, frequently and without much warning, in places that were often far from anyone who could help. The people who owned cars in the first decade of the 20th century were wealthy, predominantly male, and largely drew from professional and commercial classes that could absorb the financial and mechanical demands of early ownership. They wore special clothing for driving because the cars were open, which meant that driving at the speeds the early cars could achieve was an outdoor activity in the fullest sense. Dust coats, leather helmets, goggles, gauntlet gloves, fur-lined overcoats for winter driving. The equipment that a serious early motorist assembled for cold weather driving was closer to polar expedition gear than to the clothing a person would wear to a hardware store on a January morning. This was accepted, even celebrated, as part of the adventure of motoring. The difficulty was part of the appeal. You were doing something that most people could not do, and the discomfort was evidence of your participation in something modern and exciting. When enclosed cars began appearing in the years around 1907, the conversation shifted slightly. An enclosed car meant glass windows and a roof, and doors that could be closed, which meant that the cabin was, at least in principle, a space that could be distinguished from the outside air. The early enclosed cars were still cold because the body was not insulated and the glass transmitted cold as effectively as no glass at all, but the possibility of heating the cabin was now at least conceivable in a way it hadn't been when the driver sat in the open air. The question was what to heat it with, and the first answers that the industry arrived at were neither safe nor effective, but they established the terms of the problem in a way that the eventual solution was built against. The heater boxes that appeared in automobiles in the years before the First World War were, by the standards of any subsequent era, remarkable objects to find inside a vehicle. They were low metal boxes covered with carpet to prevent burns, into which a heated brick had been placed before departure, the brick having been warmed in a fireplace or kitchen oven before the trip began. The heat the brick provided lasted somewhere between 30 minutes and an hour, depending on the size of the brick and the severity of the cold outside, and when it was exhausted, the passengers in the car were left in the same condition they would have been in without it. The system required no engineering and no fuel, but it required planning, and it required someone to heat the brick before the trip, and it was entirely useless for trips that were longer than the brick's thermal capacity or that began without the time and facilities to prepare one.
The first engineered approach to automobile heating used the exhaust pipe, which was already hot, as the heat source. The logic was straightforward. The exhaust gases leaving the engine were at temperatures between 800 and 1200 degrees Fahrenheit as they left the combustion chamber, and even after traveling through the exhaust manifold and pipes to the point where they exited beneath the car, they were still hot enough to feel on the back of your hand from a foot away. If those gases could be routed through a duct into the passenger cabin before they exited, the cabin would receive heat without any additional fuel consumption and without any additional machinery. The system that several manufacturers and aftermarket suppliers developed through the years, around 1917 and into the early 1920s, did exactly this, routing a portion of the exhaust gases through a metal tube that ran into the floor of the cabin, where they released their heat before exiting. The problem was carbon monoxide. Exhaust gases from internal combustion engines contain carbon monoxide as a normal product of incomplete combustion, and carbon monoxide is colorless, odorless, and lethal at concentrations that can be reached in an enclosed space in minutes. A system that routed exhaust gases into a car cabin was a system that routed carbon monoxide into a car cabin, and the pipes and connections that made up these early systems were not sealed to a standard that kept the gases where they were supposed to be. Joints that were tight when the system was installed loosened with the thermal expansion and contraction that happened every time the engine ran and stopped. Pipes that were undamaged when new developed corrosion from the inside as the acids in the exhaust gases worked on the metal over months and years. The result was that the exhaust heaters of the early 1920s had a documented history of causing exactly what their chemistry suggested they would cause, which was carbon monoxide poisoning in passengers who had no way to detect the gas that was accumulating around them.
The incidents were reported, and the reports were alarming in their consistency. A family found unconscious in a parked car with the engine running and the heater on. A driver overcome on a long trip and found by a passing motorist stopped at the side of the road. The specific circumstances varied, but the mechanism was always the same. Carbon monoxide entering the cabin through a compromised exhaust heater connection, accumulating to dangerous concentrations before anyone noticed anything wrong, and incapacitating the occupants before they could respond. The exhaust heater manufacturers published warnings about the importance of maintaining the connections, and the warnings were accurate and useless because the connections failed gradually and invisibly, and the people responsible for maintaining them had no way to know when they had crossed from adequate to inadequate until something happened that made the inadequacy visible. By the mid-1920s, the exhaust heater had acquired a reputation in American motoring journalism that was difficult to separate from the incidents that had generated it. Some publications recommended against them entirely. Some manufacturers quietly stopped offering them as options on new cars. The problem they represented was real, and the solution was not, as several engineering departments were by then aware, the exhaust itself. The heat source that the automobile needed was not the exhaust, which was already committed to the task of carrying combustion products away from the engine and could not be asked to simultaneously heat the cabin without importing those products into a space where people were breathing. The heat source the automobile needed was the coolant, the water circulating through the engine's cooling system, which was already hot and which was already being managed by the radiator that sat at the front of every car. The coolant was not toxic. The coolant was not carrying carbon monoxide. The coolant was simply hot water moving in a sealed system, and if a small radiator could be placed inside the cabin and connected to that system, the cabin would receive heat from the coolant rather than from the exhaust, and none of the gases involved in heating it would be the kind that killed people.
The idea of using engine coolant to heat the passenger cabin was not invented at any single moment by any single person, and the history of who deserves credit for it is complicated in the way that the history of engineering solutions to widely recognized problems usually is. Several inventors had filed patents on variations of the concept through the 1920s. The motor car heater company, operating out of Chicago in the early 1920s, offered an aftermarket system that drew hot coolant from the engine and passed it through a small heat exchanger mounted under the dashboard. The system worked better than the exhaust heaters it competed with, and it introduced the concept to a market that was ready to find the exhaust heater approach discredited. But the aftermarket systems were imprecise and variable in their quality, and they required installation by someone who understood both the car's cooling system and the heater's requirements, which was not always the person doing the installing. The Ford Motor Company brought the coolant heater into the mainstream in 1929 with the Model A, which offered as an option the first factory-installed heater drawing from the engine's cooling system that was available in a mass-market American automobile. The system was simple by the standards of what would follow. Hot coolant from the engine circulated through a small core mounted at the front of the cabin, and air passing over that core was warmed before entering the passenger space. There was no fan, which meant that the airflow depended on the movement of the car, which meant the heater worked better at speed than at low speeds, and barely at all when the car was stopped. But it was warm air, and it came from a source that did not involve carbon monoxide, and for the motorists who had been making the choice between exhaust heaters and lap robes, it represented something that those options had not provided, which was warmth that did not require either courage or planning. General Motors moved the concept forward more systematically beginning in 1930, when its Harrison Radiator division, based in Lockport, New York, developed a heater core design for use in Cadillac, LaSalle, and Buick models. The Harrison approach added a fan to the system, which solved the speed dependence problem of the Ford design. The fan drew air across the heater core regardless of whether the car was moving, which meant the cabin warmed at idle and in traffic as well as at highway speed. It also meant that the output of the heater was controllable, at least roughly, by adjusting the fan speed, which was a form of temperature management that the purely passive designs had not offered. The Harrison heater was offered as an option on premium GM models, which meant that the people who experienced it were the people most likely to influence what the mass market expected next, a standard pattern in automotive feature adoption that would repeat itself with air conditioning, power steering, and automatic transmission in the years that followed. The adoption pattern that followed the introduction of these early factory heaters was slower than the obvious utility of the product might have suggested. The heaters were offered as options, which meant they cost additional money on top of the already significant purchase price of the car, and the additional money was enough to be a genuine consideration for buyers who were making car purchasing decisions during the early years of the Great Depression. The 1930s were not a decade in which American families were adding optional features to major purchases. The heater remained optional on most American cars throughout the decade, available to buyers who specifically requested it and paid for it, standard on none of them. The idea that warmth in an automobile might be something every driver deserved, rather than something that affluent drivers could purchase, was not yet established, and the distance between that idea and its eventual implementation would take another 30 years to close.
The problem that finally forced the car heater out of the category of luxury option and into the category of practical necessity was not cold passengers. It was blind drivers. In the winter of 1932 and 1933, the windshield fogging problem, which had been a recognized annoyance of cold weather driving since the enclosed car had been introduced, reached a level of public attention that the automotive industry could not continue to address with the answer that it had been giving, which was essentially that drivers should wipe the inside of the windshield with a rag when it fogged. The fogging was caused by the moisture in the breath of the car's occupants condensing on the cold glass of the windshield, and in cold weather, with the windows closed, the concentration of moisture inside the cabin was high enough to deposit a fog on the windshield that could reduce visibility to near zero within minutes of starting the car. Drivers wiped the windshield with their hands, their sleeves, their passengers' assistants, and sometimes with rags kept specifically for the purpose. The wiping cleared the glass temporarily, and the fog returned within minutes. It was dangerous, it was accepted, and it had been accepted for long enough that its acceptability was beginning to wear out. A Ford engineer named A.B. Arnold addressed the problem in 1933 with a modification to the existing heater design that was, in the clarity of its logic, the kind of solution that seems inevitable in hindsight. Arnold routed a duct from the heater core to the base of the windshield, directing warm air across the inside surface of the glass rather than into the cabin generally. Warm air holds more moisture than cold air, which means that warm air blown across a cold glass surface reduces the condensation on that surface rather than contributing to it, which is the opposite of what cold, damp cabin air does. The defroster, which is what this duct and its directed airflow became known as, solved the fogging problem with the same heat source that was already warming the cabin, requiring no additional machinery and no additional fuel, simply a piece of ductwork that directed the heat where it was most urgently needed. The defroster changed the conversation about car heaters in a way that cold passengers had not managed to change it. Cold passengers were uncomfortable. Blind drivers were dangerous, and the danger was visible and immediate, and not something that the industry could continue to describe as a condition that drivers should manage with a rag. Arnold's 1933 solution appeared first on Ford V8 models, and the combination of cabin heat and windshield defrosting capability made the heater a demonstrably safety-relevant feature in a way that had not been true when it was only providing warmth. The safety argument was not sufficient by itself to make the heater standard equipment immediately, but it changed the terms of the debate within the industry in a way that would eventually produce the outcome that Walter Oakes, driving to his hardware store in Duluth in 1919, would have considered extraordinary. The year 1933 was also when Ford introduced what it described as the first in-dash heater, a small gas-fueled boiler that was integrated into the instrument panel rather than mounted as a separate unit under the dashboard. This was an aesthetic improvement as much as a functional one, acknowledging that the heater was becoming a permanent feature of the car rather than an accessory bolted to its interior after the fact. The in-dash position gave the heater controls the same visual status as the speedometer and the fuel gauge, which were things that every driver needed access to, which implied that the heater was in the same category, which was not yet quite true, but was becoming more true every year.
The company that did the most to establish the car heater as a system rather than an accessory was Nash Motors, a Wisconsin-based manufacturer that occupied a mid-market position between the mass-market Ford and Chevrolet and the luxury Cadillac and Packard. In 1937, Nash introduced what it called the Weather Eye, a weather and ventilation system that integrated fresh outside air, a heater core, and controllable distribution of the heated air into a unified system with actual temperature regulation. The Weather Eye was not simply a heater with a fan. It was a closed-loop climate management system for an automobile interior, the first of its kind offered at a price that did not require the buyer to be wealthy. What Nash's engineers had understood, and what previous heater designs had not fully addressed, was that the quality of air in the cabin mattered as much as the temperature of it. Earlier heater designs recirculated the air already inside the car, which meant that on a long trip with several passengers, the air became progressively more stale and humid, which contributed to the windshield fogging problem and to the general discomfort of the cabin environment. The Weather Eye pulled fresh air from outside the car, passed it through the heater core, filtered it, and delivered it to the cabin at a controlled temperature and pressure. Nash also introduced cabin pressurization with this system, maintaining the interior of the car at a slightly higher air pressure than the outside, which prevented cold air from infiltrating through the gaps in doors and body panels that were an inherent feature of automobile construction at the time. The result was a cabin environment that was warmer, fresher, and more consistently comfortable than anything that had previously been available at any price point. The Weather Eye received the kind of reception in the automotive press that genuinely useful innovations received. It was praised not as a luxury, but as an engineering achievement that improved the driving experience in ways that were measurable and repeatable. Nash made it available across its model range rather than limiting it to its most expensive cars, which meant that the people who experienced it were not only the buyers of premium vehicles. The Weather Eye gave Nash a competitive advantage in the market through the late 1930s and early 1940s that was built not on styling or power, but on the practical comfort of the driving experience, which was a basis for competitive differentiation that the larger manufacturers had not fully explored. The other manufacturers watched what Nash was doing and began working on integrated heating and ventilation systems of their own. Harrison Radiator at General Motors developed improved systems that appeared on Oldsmobile, Pontiac, and Chevrolet models through the late 1930s and early 1940s, and by the time the United States entered World War II in 1941 and civilian automobile production halted, the integrated hot water heater with fan and fresh air ventilation had become the industry standard for new car design, even if it was not yet standard equipment across all models. The war interrupted the civilian development, but it also demonstrated the value of effective vehicle heating in military applications, where troops operating vehicles in extreme cold conditions had needs that made the comfort considerations of civilian motoring look modest by comparison.
The element missing from even the best pre-war heater designs was automatic temperature regulation. The Weather Eye and its contemporaries required the driver to manage the heat output manually, adjusting the fan speed and the valve that controlled coolant flow through the heater core to maintain a comfortable temperature. This was an improvement over having no heater, but it was still a task that competed for attention with driving, particularly on variable temperature days when the morning might require maximum heat and the afternoon might require the fan to be turned down or off. The driver was the thermostat, which was a reasonable arrangement for a simple system, but an increasingly inadequate one as the systems became more complex and the expectations of comfort became more specific. The 1941 model year, Buick, Oldsmobile, and Cadillac introduced automatic temperature control, developed by Harrison Radiator in collaboration with an Ohio company called Ranco that specialized in thermostatic control mechanisms. The system used a temperature sensing element, a small liquid-filled bellows or capillary tube, placed in the airstream coming out of the heater core.
When the air temperature at that point exceeded the driver's selected setting, the thermostat partially closed the valve controlling coolant flow to the core, reducing the heat output. When the temperature dropped below the setting, the valve opened again. The mechanism was entirely mechanical, requiring no electricity beyond the existing fan, and it maintained the cabin temperature within a range that was narrow enough to eliminate the constant manual adjustment the earlier systems required. The introduction of automatic temperature control in 1941 was, from an engineering standpoint, the completion of the concept that the coolant heater had begun. The heat source was the coolant, the distribution system was the fan and the ductwork, the control system was the thermostat. All three elements were now in place in the best American automobiles, and the system they formed together was recognizably the same system that is in every car built today. The specific components have changed enormously in the 80 years since, with electronic sensors replacing mechanical thermostats and computer-controlled actuators replacing manually adjusted valves, but the principle has not changed at all. Hot coolant passes through a core, a fan blows air across the core, a control mechanism adjusts the coolant flow to maintain the desired temperature. That is what Harrison Radiator and Ranco built in 1941, and that is what the heater in every car on the road today is doing. The war years interrupted civilian development but extended the application of automotive heating technology into conditions that civilian use had not tested it against. Military vehicles operating in the North African desert, in the European winter, and in the Pacific required heating and ventilation systems that performed under conditions that were more extreme than American winters and more demanding in terms of reliability than civilian use required. The lessons from military vehicle heating development fed back into the post-war civilian designs in ways that accelerated the standardization of the technology and the improvement of its performance under adverse conditions.
When civilian automobile production resumed after the war in 1946, the heater systems that returned with it were improved versions of the pre-war designs, carrying the advances of the wartime period into cars that were being built for a market that was ready to buy in quantities that the pre-war market had never achieved. The post-war economic boom, the returning veterans, the suburban expansion, the growth of the American highway system, all of these created a demand for automobiles that the industry worked at maximum capacity to meet, and the cars that came off the assembly lines in the late 1940s and 1950s offered heating systems that were genuinely effective by the standards of what had come before. And yet, through this entire period, the heater remained an optional feature on most American automobiles. This is the fact about the history of the car heater that most people find genuinely surprising when they first encounter it, because the heater in a car seems so obviously necessary that the idea of its being an option that the buyer had to specifically request and pay for seems like it belongs to a different era of consumer expectations than the post-war prosperity years actually were. The reasoning that kept the heater optional was economic rather than engineering. Car manufacturers competed on base price, and base price was kept as low as possible by not including anything that could be offered as an add-on at additional profit. The heater was a profitable optional extra. Making it standard eliminated that profit margin and required either raising the base price or absorbing the cost. Neither option was attractive to manufacturers who were competing primarily on the basis of sticker price. The consumer experience of the optional heater era was one that produced genuine frustration and some amount of injury. A buyer who purchased a car in November and neglected to specify the heater option, or who purchased a used car that had been sold without it, drove through the winter months without one. The car was otherwise fully functional. The engine ran, the radio played, the speedometer measured speed accurately. The heater, which by the 1950s could be installed in the car's body for a manufacturing cost that was measured in tens of dollars, was absent because the original buyer had not paid for it or because the dealer had stocked the car without it to hit a lower price point.
This was the state of the American automotive market until 1962, when General Motors finally made the hot water heater standard equipment across its passenger car line, and 1968, when the last major American manufacturer to do so followed suit. The 1968 date is worth pausing on. The hot water heater that drew heat from the engine coolant had been available as a factory option since 1929. The technology had been fully mature since the early 1940s. The cost of including it was modest relative to the price of the car, and yet, for 39 years after Ford first offered a factory coolant heater on the Model A, American car manufacturers sold new cars without heaters to customers who would drive them in winter conditions. The calculation was purely commercial, and it was defended at the time as giving customers the choice to pay only for what they wanted. The customers who drove their new cars through their first winter without heat and wished they had specified it differently might have described the calculation in other terms.
The device at the center of every car heating system from 1930 onward is the heater core. And understanding what it is and how it works is the key to understanding why the solution to the cold car problem was available for decades before it was universally applied. The heater core is a small heat exchanger, in principle identical to the radiator that sits at the front of the car and cools the engine, but much smaller, typically about the size of a hardcover book, and positioned inside the dashboard rather than at the front of the vehicle. Like the radiator, it consists of a matrix of small tubes through which hot fluid flows, surrounded by fins that increase the surface area through which heat can be transferred from the fluid to the air passing through the core. Hot coolant from the engine, the same water that circulates through the engine block and the radiator to prevent overheating, is diverted through a hose to the heater core when the heater is operating. The coolant entering the heater core from a running engine is typically between 180 and 200 degrees Fahrenheit, hot enough that air passing through the core exits at temperatures between 130 and 150 degrees, which is well above anything needed to heat a car cabin in ordinary winter conditions. The fan draws cabin air or fresh outside air across the core and delivers the heated air through ducts to the passenger space. When the thermostat determines that the cabin has reached the desired temperature, it reduces the flow of coolant through the core, which reduces the heat output, which prevents the cabin from becoming warmer than the setting requires. The remarkable thing about this system, from the perspective of the engineers who eventually built it and the historians who have examined why it took so long to build, is how little it asks of the car's engine. The coolant that heats the passenger cabin is coolant that the engine has already heated as part of its normal operation. The engine does not burn additional fuel to heat the passengers. It burns the same fuel it would burn anyway, produces the same heat it would produce anyway, and diverts a small portion of that heat to the cabin, rather than letting all of it be dissipated by the radiator into the air outside the car. The heater costs the driver almost nothing in fuel. The engineering required to build it is straightforward. The materials are standard. The manufacturing processes are those already in use for the radiator. There is no technical reason why this system could not have been standard equipment in every enclosed automobile sold in America from the moment the enclosed automobile arrived in 1907. The reason it was not is the reason that many things that seem obvious in retrospect take longer to arrive than the technology would require. The automobile industry in its first decades was organized around the priorities of engineers who were solving the problems of making the car run, not the problems of making the car comfortable, and the priorities of executives who were selling the car at the lowest possible price that would attract buyers, not at the price that included everything the car's occupants might reasonably want. Both priorities were rational within the framework of the era. Both priorities were, from the standpoint of Walter Oakes driving to his hardware store in January 1919, entirely wrong. The war years forced the American automotive industry to confront the heating problem at a level of urgency that the civilian market had not generated. Military vehicles, from the jeeps that carried officers across the battlefields of North Africa and Europe to the trucks that moved supplies through the winter campaigns of 1944 and 1945, needed to provide some degree of thermal management for the troops operating them, not as a comfort consideration, but as a performance consideration. A soldier whose hands were too cold to operate the vehicle's controls was a liability on a battlefield in a way that a civilian whose hands were cold on the way to work was not. And the engineering organizations responsible for military vehicle procurement understood the distinction clearly and communicated it to the manufacturers. The heating systems developed for military vehicles during the war were not dramatically different in principle from the civilian systems that had preceded them, but they were built to performance standards that civilian heaters had not been held to. They had to work reliably in temperatures far below what American winters typically produced. They had to work after the vehicle had been standing in the cold for hours without running. They had to deliver heat quickly enough to be useful in operational conditions where waiting 20 minutes for the cabin to warm up was not acceptable. Meeting these requirements pushed the manufacturers and their suppliers to improve the thermostatic control, the fan performance, and the heat exchanger design of their systems in ways that fed directly into the post-war civilian products. Harrison Radiator in Lockport, which had been developing civilian heating systems since 1930, was a primary supplier of military vehicle heating and cooling equipment during the war, and the engineering knowledge accumulated in that work was concentrated in the engineering staff that returned to civilian product development when the war ended. The post-war Buick, Oldsmobile, and Cadillac heating systems that appeared in 1946 and 1947 were better than the pre-war systems in measurable ways, with faster warm-up times, more consistent temperature regulation, and lower failure rates. And those improvements came directly from the military development work that had been done in the preceding 4 years. The consumer who bought a new Buick in 1947 and drove it through the winter of 1947 and 1948 experienced a cabin environment that would have been recognizable to Walter Oakes in Duluth as a genuine answer to the problem he had managed with a turned-up collar for 7 years. The air was warm before the first mile was covered. The windshield stayed clear. The temperature remained consistent without the driver's constant attention. The car was doing, in this respect, what a car obviously should do, which is to say that it was managing the environment of its occupants, rather than requiring its occupants to manage themselves against the environment. The engineering that produced this outcome had been available in principle since 1929 and in mature form since 1941. The question of why it had taken 20 years to reach the buyer of a mid-range American car in 1947 is not a technical question. It is a question about what the industry believed its obligations to its customers were, and how those beliefs changed under pressure.
The heater control panel in every car built today is the endpoint of a development that began with a hardware merchant in Duluth cranking a starter handle in January. The digital display that shows the selected temperature, the fan speed indicator, the dual zone controls that allow the driver and the front passenger to set different temperatures, these are the current expression of the same principle that General Motors and Harrison Radiator established in 1930 and that Ranco of Columbus refined in 1941. Hot coolant through a core, air across the core, a control mechanism to set the temperature. The electronics that manage the current system are sophisticated in ways that the 1941 thermostat was not, but the heat transfer that warms the cabin happens by exactly the same mechanism that it happened by in the first factory-installed heater that Ford offered on the Model A. The heater core itself, the device that does the actual work, has changed less than almost any other component of the modern automobile. It is still a small heat exchanger, still positioned behind the dashboard, still connected by hoses to the engine's cooling system, still traversed by the same hot coolant that has been circulating through car engines since the radiator was invented. a mechanic who serviced a 1941 Buick heater core and then walked into a modern repair shop and was shown a heater core from a current vehicle would recognize immediately what the component was and what it did, because what it is and what it does has not fundamentally changed in 80 years. Walter Oakes, the hardware merchant in Duluth who drove to work in January without heat for the first 7 years he owned a car, bought a new Ford in 1932 and specified the heater option, which cost him additional money and which produced warm air from a core mounted under the dashboard that was driven by the speed of the car rather than a fan. It was imperfect. The cabin took several miles to warm noticeably and was cold again whenever he stopped in traffic, but it was warmer than nothing and warmer than the lap robe he had used for 7 years, and he drove through the winter of 1932 and 1933 with something that could reasonably be described as a heater in his car for the first time. He died in 1951 without ever knowing that the car his grandchildren would drive to school would maintain any temperature they selected automatically, without their attention, using heat drawn from the same engine coolant that his 1932 Ford had also used, moving through a core behind the dashboard by a principle that had been understood since 1930 and applied at scale since 1941. The gap between understanding a principle and applying it universally is one of the consistent features of technological history, and the car heater is one of its clearest illustrations. The heat was always there. The engine produced it from the beginning. The only question was whether the people inside the car deserved to have it, and the answer to that question took longer to arrive than the engineering did.